Okay, so good afternoon. We're a small group, but uh, we're all the people that count. So, um, so we're going to go a little. We've dug into this before, and I know a number of you have done DNA testing, but over time this is changing, and as it changes, I think it's worth going back and reviewing what it is this is all about, and why, in fact, it makes sense to do it. What actually is working. So there will not be a test at the end. Um, the human DNA consists of 3 billion pairs of molecules that are well identified. And what happens is they're subject to just a little bit of mutation in every generation. As you can imagine, in all living characters, Peggy, you going to save us from our lights here? There we go. That'll help. There should be one there that says presentation. Oh, look at that. Okay. Um, so what we're talking about is as mutations occur, generation to generation, gradually you don't look like a particular ancestor 7 generations ago or 8 generations ago in your DNA because there have just been too many changes. Now, the bulk of your DNA doesn't change much. Okay. Of course, the bulk of your DNA is the same as that for most mammals. So don't get too excited. But what we tend to do is 3 things. One is ancient origins, which we were talking about earlier. What are the regions of the world your family came from? Common ancestors. Who do you share DNA with? And those are typically going to be cousins. You're not going to have your great-great-grandfather around to check. So you have to go to the 3rd cousin, which you both descend from. And then there are medical conditions and traits. Now, that was really big for a while. It's sort of toned down a little bit now. So real quick, Nobel Prize was awarded in 1962 to Watson, Crick, and Wilkins. And a large part of it was based on work by Rosalind Franklin, who was the woman who figured out the format, which is this double helix. Okay, she was a X-ray cryptographer, and whatever the technologies were of the time may have caused it, but she died of uterine cancer. And so she did not get the Nobel because she was no longer living at that time. They don't give. So this is almost insane. 3 billion pairs, but it's only of 4 compounds. And indeed, they're matched in only 2 different sequences. So all of that gives the instructions to you to reproduce yourself. So the key to genetic genealogy is over time, they have figured out there are a few places where they can consistently expect there might be a change. And so what they do is they regroup those 3 billion pairs into 7,000 places they look. And based on that, they're able to say, okay, if you have 3,500 pieces of DNA that match your mother, you know what? She probably is your mother. Okay. So of the 3 billion pairs organized into what are called chromosomes, there are 23 of them. You don't need to worry about any except one. 22 of them are just the different ways of breaking up the DNA. The 23rd is sort of cute because it consists of two things, an X and a Y. And men end up with a Y from their father and an X from their mother. Women end up with an X from their father and an X from their mother. Okay, so that's why we are what we are. The others are called autosomal, meaning non-sex. Then there's something called mitochondrial DNA. And when you look at a cell, okay, there's a nucleus that contains your DNA, and it's broken into the chromosomes. But in the exterior of the cell, there are these little mitochondria. Okay, the mitochondria give instructions to the cell as to what it should be doing. And that's what you inherit from your mother. All of us got the same mitochondria our mother had. So if you look at it, if you're a man, you got your Y from your father, who got his Y from his father, who got his Y from his father. So you can see what's happening here, right? Basically, I've got the way to track my own family among men. And since we live in a world where surnames tend to follow men, okay, if I look for how my DNA compares to other McKinneys, then I can, in fact, have an insight as to, in fact, where we might have come from originally. Okay. And that can literally, this can go back for hundreds of years and never change. Both men and women get their mitochondrial DNA from their mother. But the mother only gets the mitochondrial DNA from her mother, not from her father. Da-da, da-da, da-da. Well, while this logically is exactly the same as the Y DNA pattern for men, it's a little harder to research because women, bless their souls, change their names. So every one of these women in my family, going back as far as I can track, every one of them has a different last name. So, but I'm back about 12 generations with my mitochondrial DNA. Okay. And what, by saying going back, in mitochondrial DNA, mine matches certain people. And eventually, in looking for where the common link is, I have found a common link 12 generations back. And interestingly, I paid to have my female cousin, my father's sister, have her mitochondrial DNA done. So I actually can track my grandmother's, my father's mother's family. Obviously, I can track my mother's family. That's this. So about the year 2000, testing began with just Y DNA and mitochondrial DNA. It expanded to this autosomal 2007. Over 50 million people have been tested to date. Okay. And increasingly, this is going worldwide. So we have my wife's DNA. We have been able to make some progress with Polish DNA because there are increasing number of people from Poland still living there who have done their DNA now. Now, you really do have to find DNA. You've been, if in fact you've got family that might have come from a remote area of the world to us, Turkey, India, you aren't going to have a lot of people to test against. Okay. Whereas if you're talking about a family that's mostly European and mostly American, you have a lot of DNA. Now, this is the Indian, and it's worth mentioning because there's an important little story here. This is what happened, and people migrated over the hundreds of thousands of years. The ancestors of the Native Americans in America came from this area of Siberia. And somewhere in that line, there was a genetic mutation. And so all of the indigenous peoples in America, North and South America, have that genetic mutation. It was a mutation in the mitochondrial DNA. Okay. All of them have it. That's why you can find out that you're a Native American, among other things. It's much harder to figure out what tribe you're from, but you can figure out Native American. So these things linger. So that was wonderful, but now let's talk about genealogical research. So what you're really looking at is the common ancestor. So you're looking for a grandparent, a great-grandparent, a great-great-grandparent that you can say, oh, the DNA is really guiding me into saying I have enough DNA compared to this person to say that we're third cousins, and to track that down as to who the ancestor probably is. There are very sophisticated technologies for doing this, but what's happening over the time is that companies like Ancestry are in fact expanding how they make the DNA work. And I'll show you an example as we go through of something called cluster analysis, where they're able to look at people who have common DNA and gradually build a whole pattern of people who share the same DNA and the same ancestor. So, including people who you don't actually have DNA with, share. So there's a magic term called a centimorgan, abbreviated small c, big M. Okay? As my wife often says, it's kind of like driving a car. You can know how to turn the ignition on, but you don't actually have to know what happens underneath the engine in there. Okay? It either goes or it doesn't go. Consider centimorgans like that. All you have to know is it's the term of art. It's a technical term. But what happens is these changes we talked about, where a little bit of your DNA changes as generation to generation, is called a polymorphism. Technical term, there won't be a test. Okay, so they start by looking at these 7,000 pieces of DNA and say, okay, how many of them do you have in common with another person? Remember, this is a person who could be anything from your mother to your fourth cousin or whatever. The second thing they look at is how many join each other. You sort of think about it, if you inherit a whole block of DNA, that sort of implies that's from the same person. Whereas if you have the same number of connections, but it's all over the map. So, so they're looking for that. And so what they just do is count those cases where there are 7 in a row, and how many are there. So this is kind of an interesting chart to keep in mind if you're doing DNA. As this generation to generation occurs, lower and lower percentages of your ancestors can show up in the same DNA for you and a cousin. And does that make sense to everybody? I mean, it's sort of logical. I mean, so if you're talking to parent, grandparent, great-grandparent, it's almost 100% chance you and another second cousin will share DNA. But by the time you get to a 5th great-grandparent, a 6th cousin, that probability is down around 10%. So this is not the way you find your ancient ancestors. So this is, you can count, that's number 1, that's number 22. These are 23 chromosomes between me and my mother. Before she passed, I was able to get my mother to do a DNA test, which has helped immensely in tracking her world. And of course, one of the things that is sort of obvious is I got half my DNA from my mother. So we should be this, we should be 3,500. But you'll see there are some gray areas, and that's because over time they have found they cannot reliably test those areas. So they don't actually count. Now, this may be more interesting. This is my daughter and her grandmother. So she has 1,800 centimorgans. Now, when my daughter gets DNA from me, with the exception of the X and Y, that last specialized chromosome, okay, she could get technically all the DNA she gets from me could be from my father. Okay, it won't happen that way, but there's no reason when the random number generator goes down my DNA and says what goes to my daughter, there's no reason why it should be even. Does that make sense to everybody? Okay. So now when you get to the 23rd chromosome, the X chromosome, she matches all of that one. Well, she should, because she has an X from me and an X from my wife. That's all of her DNA. So half of her DNA or X DNA has to be from me. But all of my X DNA had to come from my mother. So this is my mother to her granddaughter. It's all of the X DNA matches. Now, this is what you'll find more typically. So this is a third cousin, Robert Reeder. He has 88 centimorgans. The blue sections, and again, you don't need them. You're just looking at the analytical. You're looking underneath the hood. Okay. Um, these are the places that my mother and Robert Reeder match. And he and my mother are third cousins. I know what the match is. Okay. So it's pretty sparse. But if you put a lot of people together, what you'll find is maybe this little area here, maybe that turns out to be Joel Martin, my mother's great-great-grandfather. You follow me? In other words, that piece of DNA Robert Reeder got and my mother got from the same guy. So this is a different way of looking at that. So take a look at the different colors. Man and wife have children. Okay. The children in turn have children. So now we've got cousins. But the amount of common that's associated with this woman is this little tiny piece. You can sort of see how that occurs. Okay. Now, I'm going to give you a link to this. So you should know that on the website, there is a table that gives a link to how to get this chart. But what this chart is it looks at each relationship and says, that's sort of the average. Let's just take a look at a niece. Here's a niece, and the average is around 1740, but the range is 1,200 to 2,200. What happened was tens of thousands of us contributed data to the man who put this table together about links we knew. In other words, we knew that this person was a niece or nephew. And we could say, okay, put it on your database. So that's what this means. And this turns out to be really interesting because it helps you as you look at someone else determine what are they likely to be in the relationship. Okay. All right. So we're going to switch over now. Okay. There we go. So one of the things this website has, and I've given you the link to this online, is you can enter for any combination the amount of common DNA. So there's our 88. Remember, that's Robert Reeder. Okay. And what it will give us is these are the likely relationships. So that person might be a half second cousin. How do you get a half? You know, dad dies and mom remarries, and now you've got a half. Does her second set of kids only share half their DNA with you? Right? Okay. Or it could be 30% of third cousin or one of these others, et cetera. Now, 88 is pretty high actually for this category. And it turns out that Robert Reeder has a secondary relationship. Those of us who are from the hills of Kentucky and Virginia recognize that more than once people were second cousins or third cousins, but they still got married. You know, why not? And I think I even have one pair of first cousins that married, but it can get pretty complicated pretty fast. Okay, but this is a good way to look at, get the information on how a relationship might be. So, now, time to go to Ancestry. Oh no. Just take me a second to do. This is my password saver. Yeah. Oh no. Don't you love these? Should have done this earlier. Sorry. All right, there we are. Finally. Okay. So we're going to look at my matches in DNA. So for those of you who aren't familiar with the Ancestry, and you will find I'm going to be selling Ancestry at this session. I think if you're doing DNA and you haven't done it before, Ancestry is far and away the best place to start. And I can give you the reasons as we go through. Okay. So we have matches by parent, by ancestor, by cluster, which we'll look at later, by location. So I have my mother and my daughter, my grandson, my first cousin, etc. Okay. And now I want to go down now till I get to Mary Lynn Shore. Okay, so Mary Lynn, um, let's look at this person. Okay. So she has a public linked tree. Okay. We can look at her tree. There's her linked tree. Now, Ancestry says, you know, she could be my second cousin because we share great grandparents. Okay. And we can view the relationship. Okay. So my relationship goes from my grandfather to my father to me. Hers goes from his brother to her mother to her. Okay. So they're doing the work for you. Okay. They're showing you how that relationship works. Okay. We can also go back. Okay. We could leave a note. She's a double second cousin, Ida Bell's daughter. Turns out her grandmother and my grandmother were sisters. So not only were her grandfather and my grandfather brothers, her brothers married sisters, which really screws up DNA analysis all the day. Okay. I can connect her to my tree if she isn't already connected. I can send her a message. Now, I'll often do a message if I'm somebody who I don't know and I want to set up a relationship with, because quite often that's a good idea. Okay. Particularly with some of my Tennessee cousins who the line split off around 1900. Okay. So I don't know anybody in that part of Tennessee. So it's awfully nice if I can get somebody there who will talk to me. Who's there? All make sense? Okay. Okay. I can set the relationship. So I can go down and I can pick a relationship. Okay. Which I haven't done with her because the one thing they don't do is double first cousins, double second cousins. They don't double like I have. So I can't automatically do it. Now I could create a group. Suppose, for example, I had Norwegian ancestry, and I had a bunch of people who came through the same towns in Iowa or Minnesota or whatever. I could say, okay, I want everybody from that town to be part of a group, right? So I can create a group. Okay. So now I want to go back. One more time. So we're going to do shared matches. So what we've got here is people that I have a lot of match with, and she has a match with too, which she should because this is my daughter. I can sort this also by her relationship. Is that one of your daughters? Peggy, is that one of your daughters or something? My sister has a different ring for every relationship she's got. So she can immediately tell me who it is. Me too. So this is Mary Lynn's relationships. Here's one that's her niece, which is also my relationship, but I can now immediately start pegging who this person is and how we're related. Um, Similar with Melanie. See what I'm doing? I'm just looking. I've organized it so the people who are close to her come up first. Okay, now I can also search. So let's say I'm going to search on um, a common family name in my side of the family. Take a second here. Well, that's not the person I wanted. There's Vicky Cadle. Okay. So here's Vicky Cadle. Um, so once again, how are we related? Okay. Let's go to her tree and see how we're related. Related to Thomas Cadle. So that's my grandmother, her grandmother. History here is Tommy Cadle had a whole batch of property in this area of West Virginia. And so my family's farm and Mary Blankenship's farm were given to her by her father. As my father used to say, it was the nearest people to where we lived. Okay, a mile as the crow flies, 10 miles by the road. Okay, so now I'm going to take a look at her tree. Okay. The Cadle branch. Okay, now here things get a little funny because what happens is there are lots of relationships. Okay. The Cadles are my family, the Holts are my family, the Ages are my family, the Maxies are my family. In other words, lots of people on here. This is that old Virginia, West Virginia people married each other. Okay. All right, now I'm going to look at another capability for ancestry. Okay, this is what they have called through lines, but basically you're going up my tree. Okay. So we're going to go back to Samuel Mitchell McKinney, my great grandfather, and you will see that it says there are 49 people in the ancestry database who share DNA with me, who also in their tree have Samuel Mitchell McKinney. So if I click on that, what I get, which I find fascinating, is this is the whole family. So Granddaddy Sam's oldest son was Tom, got 14 DNA matches there. Note that one of those is going to turn out to be Mary Lynn. There's Mary Lynn. Then there was Nancy. She and her husband were married 75 years. Of course, at the end, they didn't recognize each other, but that's okay. They were still living in the log cabin that was built for them on their wedding day. Lucy Lavina, Martha, Pollyanna, my grandfather, Mary, Charles. So in each case, I've got DNA matches. I can look at those matches. I can learn about those people, where they were from, what happened to them. Okay. Now, we're going to go back now. Okay, this really gets complicated, but that's okay. These are clusters. So this will take a minute. Okay. So we're going to leave that while we're here. Go back to the ancestry. Okay, so the other thing that happens with DNA, what we were talking about before we got started today, is origins. So what Ancestry has done, each one of the DNA sites has done this a little bit differently. But what they've done is they've taken 1,000 people who they have, through their own intensive research, identified where these people are from. Hi there.
No,
That's Sue I'm hearing.
We're can talk about DNA and cluster analysis.
Whoever that is, if you'd mute yourself, it would probably be a good idea. Okay. So the origins is the idea of where did your ancestors come from? We were talking about this earlier. In some cases, it's pretty trivial. Other cases, not. My ancestors,
Okay.
I've got England, the Midlands, Devon, Northeast England. So, control George. These are the regions that they've now defined for my family. Okay. All the way down to my 1% indigenous Cherokee Indian. But you can get a lot of information. My wife is half Polish and half French Canadian, and the Polish half is dead central. I mean, it's 50% of her DNA is from Russia, Poland, Lithuania. Okay. And it gets specific even to the region of Poland where she knows her grandmother came. We know her grandmother came from. The French Canadian side is a little more complicated because she's got people from Brittany, people from the west of Ireland, all over, but they're French. Okay. Let's go back and see if we have our clusters now. Still working on it. Okay. Well, so the thing about origins is there are going to be stray genealogy relative to the place your ancestors came from. Some people, and I think the classic is the Ashkenazi Jews, okay, they started in Germany and they ended up in Russia. Actually, they ended up in Israel. Okay, but the short answer here, but the short answer is the people who didn't seem to move still did. Okay, so for example, if you think you're Polish, your family could have grown up in what's now Belarus, what's now Ukraine, Lithuania, you know, just go down the list and still be what we think of as Polish. Okay. So don't get too hung up on this one, but it's still fun to look at. Yeah, when they talk about the origin, they're looking at about a 500-year theoretical pattern. But again, you in Europe particularly, there was a lot of movement around, so it's hard to be overly okay. So if this isn't done, we'll just let it go. All right, want to go back to the talk. So, analyzing DNA, you have to take a DNA test. Ancestry DNA test is probably the best test to do, with a few exceptions. You can transfer the results to family tree DNA, GEDmatch, and actually no longer to MyHeritage. They just changed that. You want to put your own family tree on the website. As you can see, what they're going to try and do is match these people to your family. So it's hard to do if they don't have your family tree on the website. And as is always true for DNA, if you have someone from an older generation who's still living, you may want to talk to them about getting their DNA tested. And remember, an older generation doesn't necessarily mean an older person. In other words, if you're the child of a firstborn, you could easily have an aunt or uncle who was your age. Okay. And so that person gains you a generation. Okay. In terms of the analysis. Okay. They have the largest number of family trees. Okay. You need to be a subscriber, but we'll get to this in a minute. There's special pricing when you buy a DNA test. And they don't give out the chromosome data. So if you're a techie and want to really get into the tech part, you probably have to go to another website to get that data. Family tree DNA is the only place you can get Y-DNA and mitochondrial DNA testing. Marty, just so you know, the slides will be on the website. Okay. You're welcome to take pictures still. Why mitochondrial? Didn't used to be able to. Okay. MyHeritage has really good coverage of Europe. And so if you want to have matches from people who currently live in Europe, and that's where we have found some Polish matches that have helped us a lot in looking at my wife's family. And there are specialized websites for other locations. There's actually a DNA company in India that's doing India family and origins DNA. I have a grandson who is engaged to an Indian. I'm becoming an expert. So there's some special situations. The person you match doesn't have a posted genealogy. Oops. That's where that's a good place to message them and say, and what I tend to do is say, okay, it looks like you might be related to, and see if they fight for that. Or you can, in some cases, build your own genealogy for them. Surprisingly, they can give enough information. Peter's here, yeah. We talked about, you talked about secrets today. In DNA analysis, you're going to find secrets. You will find non-paternal events. Well, that's where the world thinks that George McKinney is the father, and actually, there's a different father. And a simple one's adoptions. Okay, that quite frequently in an adoption, the family will act as though the child is a naturally born child. That's what the child has grown up believing. until suddenly, oops, that's not true. Um, Births outside of marriage. Those who've been around me for a long time know that one of my favorite cases was there was an ancestor of mine, Joel Martin, who was really interesting because he's served in both the Mexican-American War and the Civil War. Okay, had a massive file of interesting stuff about him. Okay, and somebody who, as a descendant, had written a book with all the descendants and the history of them and all that. Oops. So all of a sudden I do my DNA and I find this second cousin. And we can't figure any way we're related, but we're second cousins. And there are no mistakes at second cousin. You're really a second cousin, about. And so we tracked it down and figured out that what had happened was Joel was always believed to be the youngest child of his parents, but instead he was the child of the older daughter. Okay. And if you think about it, that's the real world happens. Um, we have a we have a unusual case that I've come across, um, which consists of a woman whose husband went off in World War I, and she had a child, and it turned out that the child was the parent that was the child of her father-in-law. And if you don't think that gets complicated in the DNA analysis, but the thing about it is there, you get one like that, there's no question. It's a math problem. Okay. You can have unexpected cousins. Yes. Okay. So the question, just to repeat it for those online, was okay, so you have a situation where you have a person who has a uh, birth father, okay, and separately has a father they were raised by. So they're part of the nuclear family, but that the father is not the right person. Okay. And I think the answer almost always is you have to be prepared to follow both. There's no other answer. Okay. You have to follow both. And in the tree, I think most people pick the natural father for the primary in the tree, but you're very careful about most databases that you can create with family trees allow you to have two fathers. Yeah. So, yeah, but I think the common is you go genetically. Yeah. Um, you have unexpected cousins. We were talking earlier about the possibility that, a la Sally Hemings' children, you could have a person who was a descendant of enslaved people, but passed as white. Okay, and you would find all of a sudden that you had this little branch of cousins. Okay, that had didn't appear to be of the same cultural background, unexpected origins. Okay, um, at one point, my wife discovered that she had English ancestors. Where do you get English ancestors when you're from French Canada? Well, it turns out there are a lot of places you can. Loyalists, other things, but it's something that you're not expecting until you get into it. We talked earlier. We talked earlier about if you have Polish ancestors, you may have Swedish DNA because there was a period of time where the Swedish people Poland was part of the Swedish Empire. Okay, the other complication is what's called endogamy. The two most common are the Ashkenazi Jewish community and the French Canadians. If there were only a small number of people to start the population and the population always intermarried, then you're going to have a lot more DNA sharing. But it's going to be lots of little pieces of DNA, not lots of big pieces. So that's one of the places where you may get a high level of DNA match, but it's not consistent with and then isolated communities. Okay, DNA testing. If you want to go to Ancestry DNA today, they'll charge you $100. That includes a 3-month subscription to Ancestry. So that typically what someone would do would be basically say, okay, I'm going to set aside a lot of my time from February to April, and I'm going to set this up so I'll have my 3 months, and then that'll let me take a really in-depth look at my DNA matches. Family tree, those are the costs for the Y-DNA and mitochondrial. They charge $39 to do their own test for the autosomal. And if you take the ancestry data and put it on their website, they'll charge you $19. My Heritage, $89 usually, is $29 on sale now. They no longer allow you to upload your ancestry DNA data. Now you get to the sad story of 23andMe. In 2006, this company started up with the idea, which was really quite brilliant, that they would link your DNA to known medical problems. So one of the more famous ones is the genetic inheritance that may cause breast cancer in women. Okay, it's not that it guarantees to cause it, nor if you don't have it, does it guarantee you won't have it. But it's one of those things that over time they expanded it to include traits, a trait being the red hair gene. There's no medical issue there, but if you have the red hair gene, it's nice to know that. They went bankrupt about 2 years ago. Many people took their tests away. They have been acquired out of bankruptcy, and I'm just waiting to see what happens next. At this point, I do not recommend using it. The reason is because the misuse of the data, meaning making it public to people who should not have data, your DNA data, okay, is unfortunately somewhat quite possible in a bankruptcy. Okay, and we won't get into the legal reasons why that's true. Okay, that's what I wanted to cover. Let's see if we have that one little chart I wanted to show you. Doesn't look like it ever finished. Okay. Okay, I'll take questions. If they're in the audience, can somebody manhandle the mic so we talk in the mic so people online can hear it? Thank you, Peggy. And we have a question. No? The button there.
Is it on?
Yep. Expert. Had a couple of good questions.
Oh.
Just a question. In order to, if you put your DNA, do your DNA test with Ancestry, and then you're matched up with others that have done that, obviously the, past generations haven't done it. How do they identify a specific individual? Does that mean that someone else in these generations has found that person through other means other than DNA to be able to have them in the genealogy?
That's a good point. The whole process of genealogical research really is resolving multiple sources of data. Okay, so you think about it from the viewpoint that I'm not 100% certain who married whom. And now I get a DNA link that says, I'm really now certain who married whom. Okay. So you're sharing this information with all of the paper trails, everything else that you have on the family to try to track it down and narrow it down. Okay. Um, some people have the blessed nature that their names are very uncommon. Other people, they're not uncommon. Okay. I had a great grandfather, William David Christian. Okay. William David Christian and William David Christian with the same name were born a mile apart in northeastern Tennessee. Okay. Within the same year. Okay. Really helpful to have the DNA to say, that's the one. Okay.
And is the DNA information on Ancestry kept, it's not kept private. You have to, say is it automatically open to others' discovery, or can you?
What's open to others is through their system. What's not open to others is a look at the detail of your DNA.
I
Okay.
see.
So let's say that in the detail of your DNA, there was some sort of a marker that might indicate a possibility of cancer. Okay. Your insurance company might want to know that. Okay. You can't get that from Ancestry.
I see. So the Ancestry test is more than just for genealogical purposes. They also give you health information. Is that
They
part
give
of
you
it?
some trait information. They don't
Trait
give you much
information.
health.
Okay.
What happened with the health information was the FDA started off saying to 23andMe, you really can't do that unless you've got our permission to do it. Because after all, I mean, does it make sense to have a public or a place you can go that's not a doctor and have that person say, bingo, you got the gene that's going to cause breast cancer. Okay. I think that's probably not a good idea.
Mhm.
So what they did was they actually went through the process of getting FDA permission for certain tests, okay, where they could say to the person, this is the test and this is what the result is.
But that information is not, again, open to the public.
Correct. And
Okay.
that's one of the reasons why 23andMe going bankrupt was such a concern, was that then there was a possibility somebody could connect the data.
Yeah.
And so what I did, and I know other people who did, I withdrew my data, which you could do. I mean, you could legally withdraw your data.
And did most people do that? You said many.
I think a lot did, yeah.
Okay,
I
but
don't know what the numbers actually are.
But if they're now been purchased by somebody else, they may just get money enough to open it up again and invite you to come back in. And,
Absolutely.
Yeah.
Absolutely. We had a question the next second on.
Can you upload your DNA to Family Search?
No, Family Search does not do DNA. Okay. There are several other websites that do very sophisticated versions of DNA analysis. They're technical enough that I find my hands full dealing with them. So, and I'm totally technical in background. So I did not put those on. Family tree DNA is very useful. And not that hard to use. If you want to get a little bit techy, that's a good one. Any questions online? Okay. That would seem to be it. Now, what we're going to do next month is talk about how your family came to California. And we're inviting as many people in Oakmont as want to come talk to tell us their history. Okay. Were your ancestors Californios? Were your ancestors gold diggers? Were your ancestors people who escaped from the Dust Bowl? Okay. Or are your ancestors just somebody who came here to go to college and decided never to go home? Okay. Or got married in World War II and decided never to go home. Okay. But how did your ancestors come to be in California? And it should be a good time and look forward to hearing. Thank you all.
This is all recorded, isn't it, George?
Yes, this is all a recording, will show up on the website. The slides are already on the website, and there's a one-pager on the website that have links if you wanted to connect to the test. Yeah. Not really. Yeah.